Hello there. Welcome to Mr. Alexander's video. It's going to be a really short video on the law of cosines. This is a topic that I would normally teach a lot more into, but in this year of distance learning, we're just going to do the very basics, the surface level on the law of cosines. And if you look at as it's written here, I'm not going to go through the proof in this video, that's too much, but if you look at as it's written here, it looks a lot like the Pythagorean theorem. Remember, the Pythagorean theorem says the sum of the squares of two sides is equal to the square of the hypotenuse. A squared plus b squared equals c squared. But that only works on right triangles. Whereas the law of cosines is like the Pythagorean theorem, but by adding this bit on the end, you can use it on any triangle. So this relationship is going to hold. But the thing to note here is that you have several sides that are involved in this formula. All of these lowercase letters are sides. They're the three different sides of the triangle, A, B, and C. But then you'll note that and A and B show up here as well. Those are the sides of the triangle, but this is the angle that's opposite of lowercase c. So these two things on either end of the formula are opposite one another. In the case of this generic diagram that I have here, we would be using this as the side C, and this is the angle C. But don't get confused by the letters. Just because it has a lowercase c in this generic formula doesn't mean that you're only allowed to use a side that has a C on it there, an A and a B, and so on. What matters is that if you know an angle like this angle here, and you know a side like this side here, this is the angle. Really good handwriting. This is the side. Those two things are opposite each other, and that's what's important, that the side on the left and the angle on the right are opposite each other. So let me show you one example of how you can use this to find a side. You can see here that we're supposed to find the measurement of this side, which right now is labeled with the letter A, lowercase a, and that's because it's across from this angle with an uppercase A. But in our generic formula, that's a C and a C. Well, does that matter? It does not matter at all, right? Those are just generic formulas. And in a generic formula, we just have to pick a letter to go somewhere. What matters is that these things are opposite. And really, in the way what I'm showing you, if you're solving for a side, the unknown side always goes in place of C. So I'm going to start by plugging in an A there, because that's how it's labeled right here. So we could say A squared equals, and then these are all known sides. So we know the length of one side is 5, and the length of another side is 7. So I could do 5 squared plus 7 squared, because that's this 5 and this 7. Okay, then the rest of it is also really important. All of this stuff is also known. So 2 times 5 times 7, because I'm using 5 for A and 7 for B. But then I use the cosine of, well, the only angle I know is this one that's 49 degrees, but it's also the angle that's across from the side I'm looking for. And that's what's really important. So the cosine of 49. And this certainly looks really scary and kind of complicated because there's so much to it. But if you look closely, you'll notice that all of this, 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 49, it's all just calculation. And you have calculators that can do that for you. So let's check it out. If I open up Google Calculator, and I, of course, always remember to put it into degree mode, first thing I do, all I have to do is punch in everything that I wrote out in my law of cosines. So 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 49. I can do all of that right here. 5 to the power of 2 plus 7 to the power of 2 minus 2 times 5 times 7 times the cosine of 49. And all of that together, just letting the calculator do the thinking, means that's about 28.08. And so, see, I did most of the work just by figuring out where the numbers go in the formula, and then you letting the calculator do most of the thinking. It's gotten a lot simpler, isn't it? It just says that A squared equals 28.08. We, of course, still need to undo the second power. That hasn't changed from any other problem. So then finally we finish it off by taking the square root of each side. And, I know the answer is about 5.3, but I'll show you that you can do it on the calculator. hit square root, and then the answer is sitting there in the memory of the calculator, 28.08. So I'll just take the square root of the answer, and then see it's about 5.3. And so using the law of cosines to find the length of a missing side, it's not that bad. It's the toughest part is figuring out where the bits go. So you put the two known sides in for A and B, and then you put the known angle in for C, and then just let your calculator do the rest of the thinking. So that's the very last trigonometry video I'm going to make. I'll see you next time when we start on coordinate geometry.